Hi guys, today on ICT we shall be taking a look at computer data conversion. We shall have a look at how the CPU converts data to information. We'll talk about some terms, register, address and bus, types of registers and their functions, differences between register and main memory, computer data processing, that's the operating procedures of the CPU, factors affecting speed of data transfer. Let's take a look at what a register is. A register is a storage location inside the CPU used to quickly accept, store and transfer data and instructions that are being used immediately by the processor. Address is also known as memory address. This is an identifier for a memory location at which a computer program or a hardware device can store data and later retrieve it. What is a bus? This is a communication system that transfers data between components inside a computer or between computers. You can think of a bus as the highway on which data travels within a computer. So what this is saying is register are like a storage, or they are a storage location, but they are located directly on inside the CPU, unlike the main memory, the RAM, which is outside the CPU. So let us move on. Let's take a look at the types of registers we have. We have memory data register. This is the register of a computer's control unit that contains the data to be stored in the computer storage, like the RAM, or the data after a fetch from the computer storage. It acts like a buffer and holds anything that is copied from the memory ready for the processor to use it. Another type of register is the CIR, the current instruction register. Is a part of a CPU's control unit that holds the instruction currently being executed or decoded. The control unit takes the instruction from this register, decodes, and executes it by sending sensitive signals to the appropriate components of the computer to carry out the assigned task at hand. Memory buffer register. This type of register stores the contents of data or instruction read from or written in the memory. In other words, this register is used to store data or instruction coming from the memory or going to the memory. So we have the program counter. This register always points or holds the address of next instruction to be fetched for execution. Memory address register stores the address of memory where CPU wants to read or write data. We'll move on. Let us take a look at differences between registers and main memory. So we'll have a brighter view of their differences, why registers are different from main memory. Register is a small amount of fast storage which is a quickly accessible location available to the computer CPU. It is a quickly accessible location available to a computer's CPU. While the main memory is a form of a computer data storage that stores data and machine code that are currently being used. So we have a few differences listed out here. Number one, there are various types of registers that perform various functionalities. That's for registers, while the RAM is referred to as the main memory of the computer. Registers are extremely fast because they are located within the CPU, while main memory is not as fast as registers because the CPU has to fetch program data from the RAM for processing. The registers hold data temporarily and sends them to the required location as directed by the CPU, while the main memory stores data and programs currently executed by the CPU. Register serves as an assistance to the main memory, while the main memory does not assist. Registers are expensive form of computer memory. Main memories are quite cheaper. So computer data processing, the operating procedures of the CPU. We're going to talk about the fetch execute cycle. The fetch execute cycle is the basic operation or instruction cycle of a computer, also known as the fetch decode execute cycle. During the fetch execute cycle, the computer retrieves a program instruction from its memory, then establishes and carries out the actions that are required for that instruction. The cycle of fetching, decoding, and executing an instruction is continually repeated by the CPU whilst the computer is turned on. Well, the steps are explained in a simple form below. Firstly, the instruction fetch. The execution starts by moving the program instruction from the main memory to the unit and then stored in its own temporary memory, which are the registers. The instruction decode. After fetching instruction, the CPU tries to decode. So instruction decode, this defines what's the task the system has to perform and where the result is to be stored. Data fetch. The CPU gets the value from the memory. That's the program instruction, the program data located on the RAM. CPU fetches it from the RAM and tries to decode. Afterwards, it executes such instructions. So let us take a look at instruction execution. The particular program instruction is carried out upon the data. That is, the instruction is executed. After execution is the instruction return. The result value of the processing is stored in a particular memory location. So that's about operating procedures of the CPU. You can see this circle here, this short illustration showing how the CPU operates. So factors affecting speed of data transfer. There are quite a number of factors that affect this transfer of data within the computer system. But we shall be focusing on the bus width and bus speed. So the factors that affect the speed of data transfer within the computer system are the amount of main memory, that's the RAM, the speed and generation of the system CPU, that's the year it was produced, manufactured, the size of the CPU register, the bus width, the bus speed, and the amount of cache memory. So let us quickly take a look at what a bus is, since we'll be emphasizing on the bus width and bus speed. A bus is simply a circuit that connects one part of the motherboard to another. This is just like another definition because we've defined what a bus is from our first page. The more data a bus can handle at once, the faster it allows information to travel. So bus width, the computer data bus width indicates how much data the chip can move through at once, and the sizes of address bus indicates how much the memory chip can handle. So the higher the bus width, the higher the amount of data that it can allow through. So bus speed, the speed of the bus is measured in megahertz. This refers to how much data can move across the bus simultaneously. I think that's quite explanatory. So having talked about that, this brings us to the end of the lesson, but let us take a look at a few points before we go. The summary: the register resides at the top of the memory hierarchy. It is the smallest and fastest accessible storage element, while the RAM, generally referred to as the main memory, is larger than register, and its CPU access is slower than register, but it is accessed faster than the secondary storage. So in essence, any program or task we launch on the computer system are carried out on the RAM, but we have the registers that are located as a memory. Registers are memory that are located inside the CPU, which makes their access faster than the RAM. But mind you, the CPU access of RAM is also faster than the CPU trying to access the secondary storage, which are the hard drives and other secondary type of storages. So that brings us to the end of today's lesson. We have a quick takeaway quiz for students. List 3 other types of registers and their functions. Outline 2 differences between registers and main memory. Explain 2 other factors affecting the speed of data transfer. Please send your answers to the email address below. Thank you for listening. Have a nice day.